Hello, today we'll discuss about the characteristics for a common emitter circuits. Static characteristics for a common emitter circuit. Here the emitter is common. So when the emitter is common, we have to draw the circuit like this. This is the emitter and the direction of this is away. Therefore, this is a NPN transistor. This is the collector current. We have to measure here current in the output circuit. This is the voltage. We have to measure the output voltage, and this is the rheostat. And this is the battery B2. And this input, we have to measure the input current. It is A1. We have to also measure the input voltage. This is V1. And this is the rheostat. We have to vary this rheostat. By varying this, we can vary the. And this is the battery V1. So this is the base current. This is the emitter current. And this is the collector current. So now, and we have to connect this here. So for the input characteristics, what we have to do for input characteristics, we have to measure this current and the input voltage. Input current and input voltage by keeping this output voltage constant. That is called as the input characteristics. And output characteristic is the characters between this current and the voltage that is collected to emitter voltage by keeping this input current constant. That is called as the output characteristics. So this is the characteristic between the input current and input voltage by keeping the output voltage constant. That is called as the input characteristics. And the characteristics between this current and this voltage by keeping this current constant, that is called as the output characteristics. So here again the procedure is to maintain the base current IB constant. Here now we have to make this current constant. If you, how we can make this current constant? Just by varying this potentiometer. So vary this potentiometer and take the reading of this ammeter and this voltmeter. You will get this output current and output voltage by keeping this input current constant. Means here we are drawing the output characteristics. So let us keep the base current constant by keeping the base current IB is equal to 25 microampere, suppose, constant, and by keeping this constant we have to note the collector current, measure collector current, and we have to measure the collector to emitter voltage. We have to measure collector to emitter voltage by this voltmeter, and we can measure the collector current through this ammeter. So measure this collector to emitter voltage by keeping this base current constant, and when you get this, again we vary this base current for suppose microampere, again measure IC and VCE, again by changing this base current and again keeping constant again at 75 microampere, again measure the collector current and uh, uh, collector to emitter voltage. So with this reading we can draw the output characteristic, that is the characteristics between the output current, collector current, which is on this y side, which is in milliampere, and the this is the collector to emitter voltage, this is in volts, and therefore by keeping this, first we are reading taken for 25 microamperes. So this, if you plot the reading, you plot the graph by taking the first reading, this is for the 25 microampere. Second we have taken for 50 microampere. So for 50 microampere your diagram will be like this. This is for 50 microampere, and for 75 microampere the characteristics will be like this. So this is for the 75 microamperes. So this is the output characteristics, as this is the characteristic between the output current and output voltage by keeping the input current constant. So this is output characteristic. And again we can draw one more characteristics between the collector current and base current. Here emitter is common, therefore we can also find a relationship between collector and base current. So here it is again collector current, which is in milliampere, and here it is a base current, which is in microampere. Okay, and if you find, take the reading, this is almost proportional. Therefore we can take the slope of this, that is change in collector current to the change in base current, and if you take the ratio of these two, this is by keeping VCE constant, that is a 4 volt, suppose, or 4 volt. We can now take the ratio of this change in collector current to the change in base current. This is called as the current amplification factor, and this amplification factor is beta. So this is a current amplification factor. Current amplification factor for the common emitter circuit. So this is the beta we have already found. Beta is equal to change in the collector current to the change in the base current for a given value of VCE, and this slope is here positive. This is the slope of graph, which is positive. So this is a beta. So now we'll see the relationship between the alpha and beta. Alpha is also current amplification factor for the common base circuit. So the relationship between alpha and beta. So alpha is the current amplification factor for the common base circuit, and beta is the current amplification factor for the common emitter circuit. So we have seen from, the figure, the emitter current is nothing but collector current plus base current. Okay, so this is for the emitter current is equal to collector current plus base current when the circuit is common base. When the circuit is common base circuit, we have seen this relationship. So therefore, change in emitter current to the change in collector current plus change in base current, we can also write like this. So from this alpha, you know what is alpha? Alpha is a change in collector current to the change in the, what is alpha? This is change in collector current to the change in emitter current. You know this is value of alpha, that is current amplification factor in common base circuit. Therefore, we can write here change in collector current, and instead of this emitter current, we can substitute this value change in collector current plus change in base current, and therefore if you separate these two, so alpha is equal to 1 plus, and this change in collector current to the change in base current, this is so for this we can write here 1 by alpha is equal to 1 plus, and this is again reverse change in base current to change in collector current. So we can write like this. So we can further write 1 plus change in base current to the change in collector current. This is nothing but the current amplification factor for the common emitter circuit, and this is 1 by alpha, and therefore this is nothing but 1 plus beta by beta, and therefore alpha is equal to beta upon 1 plus beta. This is equation suppose A, and we can also find the beta. How we can find beta now? Beta we have to find 1 by alpha is equal to 1 plus beta by beta, and we have to find this beta. We can also find from this beta alpha plus alpha beta is equal to beta, and here we can take here beta on this side minus beta is equal to minus alpha. So here we can take a beta common, alpha minus 1 is equal to minus alpha, and therefore here we can change the sign. Minus alpha beta plus beta is equal to alpha, and here if you take beta common, what will get? 1 minus alpha, and therefore beta is equal to alpha upon 1 minus alpha. So this is the relationship between alpha and beta. So this is equation number 1 and 2. So if suppose alpha is equal to 0.98, if you put here, then we'll get beta is equal to, we have seen the alpha, this will get 49. If you substitute this value in above equation, we'll get beta is equal to 49. And again, if alpha is equal to, suppose we are changing slightly, initially it was 0.98, now it is a 0.99, and if you again put this value and find beta, we will get here 99. So there is a slight, there is a too much difference between this beta. Even there is a slight change in this value of alpha. Okay, so a transistor in common emitter circuit, we have seen that in common emitter circuit, what is the emitter current? Emitter current is equal to base current plus collector current. So this is the common emitter circuit has a base emitter junction forward bias. Okay, so we can write here emitter current is equal to base current plus collector current. Now suppose when this emitter current is 0, we find that there is a still small value of the collector current. We find there is a still the small value of this collector current, and this is a leakage current. This is called a leakage current. Even there is a small zero value of the emitter current, there is a small value of the collector current, and this is called as the leakage current. Leakage current, and this leakage current is given by the symbol ICB0. The leakage current is given by the symbol ICP0, being the collector base current with zero emitter current, because this is a collector to base current, collector to base current for the emitter current 0, and therefore now we can, if you reconnect the emitter again, the if you reconnect the emitter, now the emitter current will flow, but the leakage current is still present, and therefore the total collector current we can write, this is the leakage current being collector to base current, or we can say collector base current with emitter current 0, with zero emitter current, emitter current with zero emitter current. अब बोलतो सर मी एक मिनिट बोलतो तुम्हाला with emitter current 0, zero emitter current. Okay, so now even if you connect, again reconnect the emitter current, if you connect the emitter circuit, now this current is not going to become 0, therefore we can write emitter collector current is equal to alpha I plus IC B0, and therefore you know the emitter current is nothing but base current plus collector current plus IC B0, and therefore we can solve this alpha IB plus alpha IC plus IC B0, and we can take IC on this side. IC minus alpha IC is equal to alpha IB plus IC B0, and therefore we can write here this is IC 1 minus alpha is equal to alpha IB plus IC B0, and therefore IC is equal to alpha upon 1 minus alpha IB plus IC B0 upon 1 minus alpha. And what is this? This is alpha upon 1 minus alpha is nothing but beta. Therefore, we can write IC is equal to beta IB plus IC B0 upon 1 minus alpha. So this is a collector current. Because of this leakage current present. Now the IC B0 is very small. Even though this is very small, but we cannot neglect this current, and this current is depends upon the current. If the current is more, this current is going to become more. So we have to take, we cannot neglect this current. We have to take this into the consideration. Even the small value is there, it is affect the collector current. So this is all for the characteristics of the common emitter circuits. Thank you very much for watching the video.